Hi, Amy. How
Hi,
are you?
Sam.
How are
I'm
you?
good, thank you. How are you?
Good,
Yeah,
good.
good. How are you?
Very good.
Good.
So, how's it going for you? Mathematics.
Uh, yeah, my teacher's still not back, so kind of like still learning. We moved on to pure maths now. Learning it like kind of by myself, and then stats. It's kind of tricky, but yeah, I'm still trying to get my head around it. So
Okay.
yeah.
So, I looked into some of the questions which you had sent on mechanics. So, I thought I'll take one of them and discuss it in details. And that should help you to solve most of the problems based on constant acceleration and similar type of examples, right?
Yeah.
So, I was actually thinking like how to explain you because I wanted to understand what kind of difficulties you are facing in understanding the question. So I hope if that is addressed, then you'll be able to
Yeah.
answer all the questions, right? That's the whole idea. So let me share
Yeah.
with
I'm
you the
definitely
screen.
finding. Yeah, I'm definitely finding. I've got my tests next week, Tuesday,
Okay.
and it's the modeling and mechanics which I kind of like get
Mhm.
a bit more better than the whole constant acceleration thing. I know we've done a couple of videos on it. It's
Yeah,
just like when it comes to the questions, I'm not really like yeah. So when we go through this, you'll see like where I'm like just not getting it. Like I just don't get it. So
yeah, sure.
yeah, hopefully
How,
after
how
this
was your
lesson it'll be
maths challenge? I mean, how was your maths challenge?
Oh yeah, I got a bronze certificate. So
That's
there's
great.
bronze, silver, and gold. Yeah, and out of like the people in my class as well who decided to do it, they didn't really get like any certificate. So I'm glad I even got bronze, which is still like an achievement considering like the limited time that we did it in. So yeah, I guess after doing that, I'll get a bit more idea when it comes to year 13 and be a bit more prepared. Yeah,
That's very good. Excellent.
yeah.
Congratulations.
Thank you,
We hope
thank you.
for gold next year, you know?
Yeah,
Yeah. Okay.
hopefully.
Great. So that's encouraging. Now, here is the question which we are going to discuss, Amy. I'd like you to read the question, and while you read, also share with me what kind of difficulties you could face in, answering such a question, right? So, this
Okay.
is a very general question, no values given, all are like variables. Okay. So, can you please read the question?
Okay. An object P is moving on the x-axis with a constant deceleration a meters per second squared. At time t equals to 0, P passes through the origin O with velocity u meters per second in the positive direction. The point A lies on the axis and OA is s meters.
Hmm.
A. Find the difference between the times when P passes through A.
Hmm.
B. The total distance traveled by P during the interval between these times.
Correct. So, what is the kind of difficulty which you have in answering this type of a question?
Okay, if I could just talk through like what I would do, and then
Yeah,
you
yeah,
could tell
sure,
me
that'll be
like
great.
where I'm going wrong.
Yes, yes,
Okay,
yes.
so find difference between the times when P passes through A. So yeah, I would start with like a diagram, and
Right.
then I would plot. First, I would like kind of read the question again. So and then like do what you said and do the suvat, and then fill in the stuff, the values that I have, and then values I need to find.
Correct.
So we got if I write like suvat, can I
Yeah.
write on this or no?
Sure, sure.
I don't know
You
how
can tell me,
Zoom
all right.
works.
You tell me,
All
all
right, okay. So write suvat on the side, and then acceleration would be, since it's constant deceleration, it would be minus a meters per second squared.
yes.
And then at time t equals to 0.
Yeah.
So where you wrote, we were saying it passes through the origin O. So at O you would write t equals 0,
Okay.
and then write under O as well. Velocity is u meters per second. In
Correct.
the positive direction, so it would be to the right.
Yes.
And then point A lies on the axis as well. So yeah, that distance between O and A is s meters.
Mm-hmm.
So yeah, find the difference between the times. So we need to find the time at that point A. So if we've got we've got the velocity, we've got the acceleration. No, we've got the initial velocity. So we've got u We got acceleration. We got the distance. So we've got U, A, and S. U, A, and S. Yeah,
Okay.
that's the equation. Then you find the time.
Perfect. So
Okay.
practically, that is how you're going to do it. So exactly what you said, when you have all this kind of a question, write all the values and identify which equation will work for this question. So S equals to ut
Yeah.
plus half at square really worked. And you'll realize that this displacement equation, which is ut plus half at square, is a quadratic equation. And that really means that, and in this case, we are talking about deacceleration. That really means that the the term here will actually be negative, correct? So that is
Hmm.
kind of a parabola, which is going to be like this, and this parabola is going to strike at two different points, and those are the two times which we need to figure out, right? So the
Right.
particle is moving along the x-axis, but it right goes in this particular direction and then also returns as shown in this green line. So that is the path of the particle, and it returns. And when it returns again, we have to find the second time when it is at A. And we are interested in finding the difference between the times when P passes through A. So that means difference between these two times, T2 minus T1. And then the second part is during this time, what was the distance traveled by the particle? So these are the two type of questions which we are going to answer in this particular video. Okay. So let's
Yeah.
begin with the general thoughts about it, just as you were sharing with me your thoughts. Now, when we read this question second time, as you were saying, an object P is moving on the x-axis with a constant deceleration. Very important. That really means that the A value, the acceleration value is negative A, right? So this is important to figure out. Then you write down, you make a diagram as shown here and mark all the things which are given to you. Initial velocity as u is given to us, acceleration of minus a is given to us, and the distance between 0 and a is capital S. So we mark all these things. And as you said, we know we are given initial velocity and acceleration. We need to find time. We are also given the distance. Therefore, we can use this formula S equals to ut plus half at squared. Rearranging this formula, we get a quadratic equation. That quadratic equation can be solved with a quadratic formula, minus b plus minus b square minus 4ac over 2a. Substituting the values, we'll get the value of t. So that is going to be our solution. So now, let's put the values which we already have. So in this particular case, as we discussed earlier, we have V0 equals to U, A as minus S, S is capital S. When we substitute these values, what do we get? These are the values given to us. So the equation now becomes S equals to capital UT minus half AT squared. Bringing all the terms to one side, we get this quadratic equation. Using the formula, we get the value of t, and that simplifies to this particular formula, where obviously, if the square root term is greater than equal to 0, you're getting to get two times, and difference between those two times will give you solution to part A. Perfect?
Yeah.
Now let's put some values, because depending on the values, you'll get some answer, right? So what we have done here
Hmm.
now, we have replaced the capital U with 4 meters per uh, constant acceleration by 4 meters per second square. So the acceleration is given to us as 4 meters per second square. At t equals to 0, P passes through this point with initial velocity of 14 meters per second. So we'll written U as 14 meters per second, and the distance S in between has been given now as 12 meters. So we have S as 12 meters. We know the formula S equals to ut plus half at works. Substituting these values, we get our equation, which is 12 equals to 14t minus half 4t squared. Rearrange, and then this was simple equation. I took the value so that you could use factoring and get the answer. So once you factor, you get t minus 1 times t minus 6 equals to 0, and you get two different times, which is t equals to 1 and t equals to 6 when the particle passes through the point A. And the difference between these two times will give you the answer, which is 5 seconds. Clear, right? So when
Yeah.
the values are given, it becomes much more simpler. Just substitute the values, get your answer. Now, part B is to find the distance during this interval, which was traveled by the particle. Now, distance traveled is a tricky part since distance is a scalar quantity, correct? So,
Mhm.
at T1 and at T2, actually speaking, the particle crosses A and then comes back. So, at both the times, displacement is zero, right? It is at this point, correct?
Yeah.
So displacement is zero. However, it has traveled a distance going to the maximum and then coming back. So what we are now interested in finding is how much distance did it travel maximum away from the point and then return. This is what we are interested in calculating. You get the idea. That is
Oh.
how we can find the distance traveled during this time. You understand this part B now?
But but why won't it be between? I know O. So O and A, that distance is given, which is 12 meters.
Yes.
But between because we just calculated the time, and the difference between the time were 5 seconds. So are you saying from going like after that point A and then coming back, that's 5 seconds?
So this was the difference between the two times coming and going back. But we also know both the times when the particle is at A. You get the idea,
Yeah,
right? So let me
yeah.
explain
Which
you.
was like the T equals
Correct. So let me
6
also
stuff.
explain
Okay.
you with the graph so that you could picture this and remember. So basically, as you
Okay.
can see here, I plotted the graph. This particular graph shows the displacement. You see that displacement? The particle crosses the origin, goes to some maximum, and then returns. What are we interested in? We are interested in finding the time when it crosses A, right? So during this time, we can clearly see that the particle goes some distance away and then returns by the same distance. Correct? So that becomes
Yeah.
the situation. The acceleration is constant, is given to us as negative. This is your negative acceleration, which is A equals to minus 4 meters per second square. And V equals to U plus AT. So that graph shows here is the velocity. V equals to U, which is initial velocity of how much? 14 meters per second, right? Plus A, which is minus in this case, right? Minus 4t. So that becomes the equation of the velocity. I'm only giving you these things once again here, since the question could have parts C, D, E, many other parts, in which you may be required to find velocity at different intervals. You may even be required to
Mm.
sketch this particular graph, which I've sketched before you. Correct? Now, the particle which is stationary is shown here. This is the particle which is 12 units away from the origin. Now, clearly, it is striking at 2 points, and these 2 points are the times which we just calculated as 1 and 6. So that diagram actually gives you the complete situation. Now, coming back to the question, where we want to find the distance traveled by the particle during the given interval. So the easiest way is from point O, find the maximum distance particle is traveling. Because at the maximum distance, this is a turning point. At turning point, the final velocity is going to be zero. So we can actually find that if acceleration is given to us as minus 4, velocity is given to us as 14, and final velocity is zero, what is the displacement? That is the whole trick. So we are given the acceleration of minus 4, initial velocity of 14 meters per second. Now, this displacement at turning. So when this turns, that is the maximum displacement. That is what we are trying to figure out. At that point, the velocity, the final velocity is zero. Now we can use the formula v square minus u square equals to 2as, rearrange, s is v square minus u square over 2a. Substitute the values, you get the maximum displacement as 24.5. So now we know that this distance here is 24.5 from here to here, the
Wait.
total distance.
How come we're doing displacement if we're trying to find distance?
Yes, so that is the next step. So now we know that this particular point is 12 units away, right? So this distance is going from here to 24.5 and coming back the same distance. So as you can see, from here, 24.5 minus 12 is one side, the other side also same, times 2 gives us the total distance of 25 meters. You get the idea?
No, I do. It's just I think I need more practice.
Yes, see, what we found is, let me clear this. From 0 to maximum, the displacement was 24.5 units. We want to find how much distance was traveled. So in this direction, distance traveled was 24.5 minus 12, because this is 12 units away.
Oh, yeah.
And then
okay, that bit I got.
And it returned the same. So times 2. 25 meters is the total distance traveled by the particle during this time. You get the idea?
Oh, yeah. No, it actually does make sense now. So S, just to clarify, means displacement, right? In the Suvac equation.
Yes. S is
so you need to use the S to find the displacement. Then from that, you find the distance.
correct.
Oh.
So we found the maximum displacement. See, since the particle goes through that point twice, that means it is turning back and then going through that point, correct? So we find the turning point. Turning point will be the maximum displacement. And at turning point, the velocity is going to be 0. That helps us to find the maximum displacement. And from maximum displacement, we find our total distance traveled during that time. So it's a very important question and a difficult question to answer. You get the idea now?
Wait, so the only way you found the turning point is by drawing the graph. You couldn't have done it any other way.
Oh, we could have done, because we know at turning point the velocity is 0, right? And therefore, we could directly use this formula v square minus u square equals to 2as and find the maximum displacement. You get the idea?
Oh, okay. Yeah.
And so we'll get graph definitely helps us to understand the overall situation. Second, as a part of your question, part C could be graph this situation. You get the idea? So, so you may be required to sketch velocity and time graph, acceleration and time graph, which is a constant, but displacement and time graph. That could be another part of the question, correct? Right? So now you can try this question with some other distance. You can change the distance from 12 to something else and then figure it out. The only thing is, only this calculation will change. Get the idea? And you'll be able to find out. Anyway, the method is going to be same. Perfect. So that is how you answer these types of questions. Do you completely understand it?
Yeah, I do.
Perfect.
It's just, I know you obviously can't go through every single question. Then some new thing pops up and I'm like, oh, what do I do? And I know it's something to do with Suvat, but like it's it's just not working. Do I have to memorize all these equations, or
do they
give
only these 4 equations you should
formula
remember?
booklet?
These formulas, right? They were last time we derived all the formulas, right? From v equals to u plus at and average velocity into time is displacement. You get these formulas very easy for constant acceleration.
Okay,
And there, once you do 10, 12 questions, you'll always remember them. Perfect. So that is the first part of our learning. I'd like you to summarize, like, what did you learn in solving such a question?
So the main thing is once you've read the question, first label like all the Suvat things that are given in the question and things then you need to find. Diagrams are always needed to like see what is actually going on. And like we've shown here with the labels, graphs are very important because I think I also, when I picture things and questions, it's always in a graph form, so I can get a nice like visual. So like when you showed the velocity is 0 at the turning point, that was really clear from the graph because it's like a straight line when you draw it at the turning point, and stuff like that. So that's very important. I think it's just about kind of breaking down the question into more
Perfect.
easier sections so you can like understand it.
That's good. Yeah.